Professor Baldwin here, and today we're going to solve exponential equations and logarithmic equations. First, we have a couple of properties. Our first property is the base-exponent property, and it says that if you have two exponents and they have the same base, notice that they both have base a, then those exponents, x and y, are also equal. The second is the property of logarithmic equality. If you take the same type of log, so log with the same base of both sides, then what you are taking the log of, here m and n, are also equal. Let's look at a few examples. Example 1. We have 3 to the x equals 81. We want to solve the exponential equation algebraically. Well, can we rewrite 81 as 3 to some power? We sure can. So 3 to the x equals 3 to the power of 4. And we apply that base-exponent property. They both have a base of 3, which means that those exponents are equal, or x equals 4. Now we want to look at a little more challenging of an example. Example 2, we have e to the x plus e to the negative x equals 5. Well, first let's deal with this negative exponent to see what we really have. And remember that a negative exponent is the same as moving that value down to the denominator with a positive exponent. At the same time, I'm also going to subtract 5 from both sides. Okay, now we have a fraction, and we don't really like fractions, so let's multiply the whole thing by that denominator of e to the x. So we'll end up with e to the x squared plus 1, because e to the x times 1 over e to the x simplifies, minus 5 times e to the x equals 0. Now, notice if I change places for terms 2 and 3, I have e to the x squared minus 5 e to the x plus 1 equals 0. You notice how our first term is something squared and our second term is minus 5 times that something plus a constant equals 0? That looks just like a quadratic, right? It does. And we're going to use u substitution. So we're going to let u equal e to the x. And doing that, we get u squared minus 5u plus 1 equals 0. Definitely looks like a quadratic now. I can tell right away that I can't factor this, so let's use the quadratic formula. And that'll tell us that u equals negative b. How about we write our a, b, and c down? A is 1, b is negative 5, and c is 1. So negative b would be 5 plus or minus the square root of b squared minus 4ac over 2a. I'm going to simplify this for you, and we end up getting 5 plus or minus the square root of 21 over 2. And that's what u is. But at this point, we want to change back to say that e to the x equals this 5 plus or minus the square root of 21 over 2. Now, how do we solve for x? This is where we're going to use that second property, the property of logarithmic equality. If I take the log of both sides, then what I'm taking the log of ends up being equal. Well, since we have e on the left, we're going to take the natural log of both sides. The reason we take the natural log is because we also use that property where the base of our log, e, for a natural log, and the base of our exponent, cancel each other out, and we're left with x equals the natural log of 5 plus or minus the square root of 21 over 2. Well, now we need to actually calculate the natural log of 5 plus or minus square root of 21 over 2 to find out what x is. We're not doing this by hand. Let's bring up our calculator. And we want to put in the natural log of, we want to make sure we have a distinct numerator and denominator. Let's do the plus version first. 5 plus the square root, so we have to hit second and then the square root of 21. Notice that we're still within the square root, so we need to arrow to the right to close those parentheses. We have our numerator, now divide by 2. We have our denominator, close the parentheses and hit enter, and that's the solution for 5 plus the square root of 21 over 2. We want to do the same thing, but for 5 minus the square root of 21 over 2. Oops. See, if you don't hit the arrow key, you end up staying inside those parentheses, which happens more often than I would like to admit. Okay, here we have the minus version. And we have our two solutions. So x equals 1.567 or negative 1.567. This next example, we need to solve this logarithmic equation algebraically. We need to use a bunch of different properties here. First, we're going to convert this from a log to an exponent. Remember, we can write that e. So we start at the base, and it's to the power of 5 equals what we were taking the log of. So 2 to the power of 5 equals 10 plus 3x. 2 to the power of 5 is 32, so 32 equals 10 plus 3x. We want to isolate x, so let's subtract 10 from both sides, and we're going to get 22 equals 3x. Divide by 3, and we get x equals 22 thirds. How about this next example? Log base 6 of x equals 1 minus log base 6 of x minus 5. First thing you should notice is that both logs have the same base. So let's put them together on the same side. So let's add log base 6 of x minus 5 to both sides. Then we have log base 6 of x plus log base 6 of x minus 5 equals 1. Well, remember our log properties? We can combine these two logs into one using the product rule. So that is log base 6 of x times x minus 5 equals 1. Now I'm going to convert it from a log to an exponent. Start at the base 6 to the power of 1 equals what we were taking the log of. So 6 to the power of 1 equals x times x minus 5. 6 to the power of 1 is 6. Distribute the x on the right-hand side to get x squared minus 5x. Let's subtract 6 from both sides. And notice that we have a quadratic again. We have x squared minus 5x minus 6 equals 0. This one we can factor. Our factors, so two numbers that multiply to negative 6 but add to negative 5 would be negative 6 and plus 1. Solving, we'll get x equals 6 and we'll get x equals negative 1. You need to check these. So the biggest check is these values, x equals 6 and x equals negative 1, to make sure we can actually take the log of them. Well, we can't take the log of a negative number, so we can immediately throw x equals negative 1 out. And in fact, our only solution is x equals 6. Moving on to page 2, we now need to use our graphing calculator. And we're told to use our graphing calculator to find the approximate solutions of the equation. We could have done this technically for the one before, but we wanted to work it out by hand first. Let's do this one with the calculator. Applying that same product rule, we can combine these into one log. Log of base 8 of x times x plus 2 equals 2. Well, we want to be able to graph this, and you can't graph a base 8 log. You can only graph a base 10 or a natural log. So we're going to use the change of base. So our numerator is what we were initially taking the log of, but with base 10. And the denominator is log of base 10 of the value of our original base. Now we're going to go to our graphing calculator. We're going to go to the y equals, and we're going to plot both of these. So first we're going to plot the log. Let's do parentheses so that we can make this a definite numerator. Log of x times x plus 2. Close the parentheses and divide by log of 8. And we want to know when it's equal to 2, so our second line will be 2. And then we can graph. Well, notice we have 2 points of intersection, but the point of intersection on the left would be a negative value, and we can't take the log of a negative value. The only reason it showed up this time is because we did that change of base. So we need to use our trace function, so second trace, in order to find the intersection of those two lines. So we're going to hit 5, and it wants to know, is this our first curve? We need to make sure we're on our first curve. Check the equation up top, make sure that it is correct. It is, so we hit enter. Is this our second curve? It equals 2. It is. Do we want to guess? Yes, we do. Notice that our point of intersection is here on the right-hand side, and we want to look at what our x value is to get a y of 2, and that is an x value of 7.06. So our solution is that x equals 7.062. Let's look at another example where we have to use our graphing calculator to approximate the point or points of intersection. Notice we have two separate equations. Sometimes they look like they run together. They're not. These are two separate equations. The first, this is technically a line, right? But we need to get that y by itself in order to enter it into our graphing calculator. Let's subtract 2.3x from both sides. That'll give us 3.8y equals negative 2.3x plus 12.4. We need to divide everything by 3.8, in order to get y isolated, right? We need y isolated because that's how you enter it into your calculator. So y equals, and we can just leave this as a fraction and let our calculator deal with it. Okay, we have our first equation and we have our second equation, right? And it's a natural log, which we can put into our graphing calculator. So let's switch over to our graphing calculator. We need to go to our y equals and we need to clear out any equations that we have in here. Okay, let's enter our first equation. I'm going to do parentheses so I can get this first fraction in. Remember to use the negative symbol and not the minus. So it's negative 2.3 divided by 3.8 times x plus, let's do parentheses again, 12.4 divided by 3.8. Okay, our first line is in there. Now we need to enter our second function, which is a log function. And that is 1.1 natural log of x minus 2.05 and close our parentheses. Let's graph. There we have our line and then we can see our log function. And we want to know the point of intersection, right? There's just one. Remember that second trace intersection is 5, so we enter 5. This is where we confirm that we have our curves. So this wants to know if it's our first curve. Double check that you entered everything correct. Yes, so hit enter. Check your equation for your second curve. Correct, so enter. If you keep on seeing that question asking if it's your second curve or your first curve and you're hitting enter and nothing's happening, you may not be on the actual curve. So just hit the arrow button until you can see the little flashy point that you're on the curve. So here I'm actually on the curve, so I'll hit enter. Now I'm prompted, do we want to take a guess at that intersection? Yes, definitely take a guess. I don't want to do that calculation. I hit enter. And there's my intersection, 4.09 for x, and y is 0.79. So our intersection is the point 4.09, 0.79. I hope you're feeling a lot more comfortable with that graphing calculator and with some of these exponential and logarithmic equations. If you still have a question or you come across a problem you need help with, let me know.